Intro. Deep beneath the calm, vast surface of the Pacific Ocean, the very crust of our planet is tearing itself apart. And this isn't some slow, gentle stretching over geological time. We're talking about a violent, irreversible fracturing of the Earth, happening in dramatic, energetic bursts. A massive wound is opening up on the seafloor, creating a landscape of permanent instability. It's a process that's been going on for millions of years, and all the evidence tells us it has no intention of stopping. Section 1. The epicenter of the fracture. To find the source of this incredible activity, our journey starts thousands of miles off the coast of South America, in water over 2.5 kilometers deep. This is the East Pacific Rise, a colossal underwater mountain range that's part of the global mid-ocean ridge system, a 65,000-kilometer-long seam that wraps around our planet like the stitching on a baseball. The entire ridge is a boundary between tectonic plates, but one specific spot is getting a lot of scientific attention, a segment at a latitude of 9 degrees 50 N. Here, at what's called the EPR 9 degrees 50 N, the seafloor is spreading apart at one of the fastest rates on Earth. The Pacific Plate to the west and the Cocos Plate to the east are moving away from each other at over 10 centimeters a year. Now, that might not sound like much. It's about how fast your fingernails grow, but on a planetary scale, that is a blistering pace. This rapid separation makes the East Pacific Rise a place of immense geological drama. You've probably heard that we know more about the surface of Mars than we do about our own planet's seafloor. Well, that statement has never been more true than it is right here. For decades, we pictured seafloor spreading as a pretty uniform, steady process. But recent discoveries, using tech that can map the abyss in stunning high resolution, have revealed a far more chaotic and violent truth. The seafloor isn't just stretching, it's being actively broken from below. And to understand why, we need to look deeper into the engine room of the planet itself. Section 2. The planetary conveyor belt. The engine driving this relentless cracking is a process called seafloor spreading. A good way to picture it is to imagine the Earth's tectonic plates as giant passengers riding a planetary conveyor belt. That belt is the Earth's mantle, a sea of semi-molten rock that churns in slow motion, all thanks to the intense heat of the core. And where these currents of rock rise, they push up against the cold, brittle crust of the ocean floor. This upwelling of heat and material is what creates mid-ocean ridges like the East Pacific Rise. As the mantle currents flow in opposite directions, they drag the tectonic plates apart. It's an unstoppable force, powered by the thermal engine of our planet. As the two plates pull away from each other, a gap opens up away from the ridge, like new material being added to the start of the conveyor belt. Over millions of years, this very process creates entire ocean basins. The Atlantic Ocean, for instance, was born this way and is still getting a few centimeters wider every year. This conveyor belt model is a great way to understand the basics of plate tectonics. It explains how oceans are born and why continents move. For a long time, it was the accepted story, a steady, continuous creation of new seafloor. But the real story at EPR 9 degrees 50 N is turning out to be a lot more violent than this simple analogy suggests. The process isn't the smooth roll of a conveyor belt. It's more like a series of brutal, sudden ruptures. Section 3. The violent reality of magma power. So, the simple model assumes magma just passively fills the gap as the plates pull apart. But what scientists have discovered at EPR 9 degrees 50 N paints a much more aggressive picture. Beneath this part of the ridge lies a shallow chamber of magma, a lens of molten rock that is over-pressurized, like a balloon inflated to its breaking point. This immense pressure completely changes the dynamic. The magma doesn't just wait for a gap to open, it actively forces one open. Using incredibly detailed 3D seismic imaging, researchers have been able to peer beneath the seafloor and see what's really going on. They found that the magma chamber periodically injects vertical sheets of molten rock, known as dikes, straight up into the crust. These dikes act like superheated hydraulic wedges, splitting the seafloor apart with incredible force. So the cracking isn't just a passive response to the plates pulling apart. It's an aggressive, magma-driven fracturing from below. And it happens in sudden, energetic bursts. Instruments placed on the seafloor here have recorded abrupt fault movements and the rapid formation of new fissures happening within months, not the thousands of years we once thought. This is geology happening in real time. Scientists now have evidence that the magma chamber itself is being refilled from an even deeper source, creating a bottom-up trigger for eruptions and these fracturing events. What's truly amazing is how precise this all is. The latest research shows a stunning vertical alignment between the shape of the magma chamber below and the faults that appear on the seafloor above. Ridges and troughs on the surface of that magma body directly predict where new cracks and fissures will form. The magma chamber is essentially leaving an imprint on the crust, predetermining where future points of failure are going to be. This isn't random cracking. It's a direct and violent conversation between the molten heart of the ridge and the brittle crust above it. Section 4. Raising the stakes. The Ring of Fire. Connection. So, why does a crack in the deep Pacific matter to us on the surface? Because this act of creation in one part of the world is directly linked to destruction in another. The East Pacific Rise is a major piece of the Pacific Ring of Fire, that infamous zone of intense seismic and volcanic activity that encircles the entire ocean. While the cracking at the ridge itself generates thousands of small earthquakes, its real importance is how it drives this larger, planet-shaping system. The new crust being violently generated at the East Pacific Rise pushes the massive Pacific Plate to the northwest. This relentless push is the engine behind some of the most powerful geological forces on Earth. As the Pacific Plate moves, its edges are forced to dive beneath the surrounding continental plates in a process called subduction. This is where the world's most powerful earthquakes, or megaquakes, and most explosive volcanoes happen. Think of it this way. For new plate material to be created at the East Pacific Rise, old plate material has to be destroyed somewhere else. This cosmic recycling happens at the deep-sea trenches that line the coasts of Japan, the Philippines, Alaska, and South America. The stress that builds up as the Pacific Plate grinds under these continents is what will eventually be released in catastrophic earthquakes, like the ones that have devastated places like Japan and the Cascadia region. The ever-widening wound at the East Pacific Rise is constantly adding energy to this system, making sure the Ring of Fire lives up to its name. The fracturing at the ridge also provides direct pathways for superheated, mineral-rich water to escape from below, creating the iconic hydrothermal vents we call black smokers. These vents support unique ecosystems that thrive in total darkness. But they're also a stark reminder of the immense heat and pressure just below the surface, the same forces that drive volcanic activity all across the globe. The cracking of the seafloor isn't some isolated event, it's a fundamental beat in the heart of a living, breathing, and often violent planet. Conclusion. The story of the East Pacific Rise is an incredible reminder that our planet is anything but static. Down in the crushing pressure and absolute darkness of the deep ocean, the Earth is locked in a constant, powerful cycle of creation and destruction. The cracking of the Pacific seafloor isn't a flaw. It's a core feature of our dynamic world, driven by the same internal heat engine that has shaped our continents and oceans for billions of years. The evidence is clear. This process is irreversible. As long as the mantle churns and the plates are dragged apart, magma will keep forcing its way upward, splitting the crust in violent, sudden bursts. The landscape of the East Pacific Rise is one of permanent instability, a place being perpetually reborn. That wound in the Pacific isn't going to heal. It will continue to widen, to crack, and to drive the grand, unstoppable march of plate tectonics, shaping our world in ways we are only just beginning to truly understand. The seafloor is cracking, and it won't stop. CTA. If you want to continue exploring the incredible and often hidden forces that shape our world, make sure to subscribe and click the notification bell. And we want to hear from you. Let us know in the comments below. What geological mystery should we investigate next?